8.2 is the substitution method. We're going to talk about the substitution method, and this is the method that you're going to end up using quite a bit. You've actually used something similar to this method already, so it's going to start to look a little bit familiar to you. So the substitution method. The first objective here is to solve a system of equations by substituting for a variable. That is, if I have x equals y plus 4, and I have the equation 2x plus y is equal to 5, I can plug this entire piece in for my x. So, if I give you an equation like this, if x equals 6 and y equals 3x plus 2, what does y equal? Well, we've done something like this at the beginning of the year where you just substitute in, since we know x is equal to 6, we're going to plug in 6 into our x. So we end up with y is equal to 3 times 6 plus 2. So then y is equal to 18 plus 2. Y is equal to 20. And we've done something like this before, that if we know what x equals, we can solve for what y is equal to. On something similar, if I say if x equals y, and then we have and y is equal to, not y is equal to, and 2, put this down below, 2y plus x equals 6, can we solve for y? Well, we know that x equals y, so I can plug y in for my x right here, and I can find out that 2y plus y is equal to 6, so 3y is equal to 6, y is equal to 2 in this case. So all we're doing is we're substituting one variable in for another. So let's look at this one and do substitution. X plus y is equal to 6, and x equals y plus 2. So I'm going to substitute in y plus 2, because it's equal to x, in for my x value. So I give myself a big, and anytime I see an x, I'm going to substitute y plus 2 in. So y plus 2, parentheses, plus y is equal to 6. Now I'm going to keep solving, and I get y plus 2 plus y is equal to 6. 2y plus 2 is equal to 6. 2y is equal to 4, because I subtracted 2 from both sides. So y is equal to 2. I'm not done yet, though, because I need to solve for both x and y. So once I get y is equal to 2, I can plug it back in, and I'm going to plug it into this equation. X is equal to 2 plus 2. So x is equal to 4. So this equation is equal to each other. The systems are equal to each other at 4, comma 2. And that is how I solve my systems. You should end up, our final piece should be a point. So we're going to do this one again. Solve by using substitution. Notice here that neither one of them are solved for a single variable. So my first step is to solve an equation for a single variable. And I'm going to choose this first equation right here, and I'll write it as equation 1 and equation 2. I'm going to do that to equation 1, so I end up with x minus 2y is equal to 6. So I'm going to add 2y to both sides, so x is equal to 6 plus 2y. Now once I have it equal to a single variable, I can then take this piece right here and substitute. So my next step would be to substitute the single variable equation into the second equation, or the other equation. We'll write it as the other because it might not always be the first equation. The other equation. So when I go to substitute this in, I get 3 parentheses, because I see an x, 6 plus 2y plus 2y is equal to 4. So my last step is then to solve. Step 3 is to solve. So I'm going to distribute, and I end up with 18 plus 6y plus 2y is equal to 4. 18 plus 8y is equal to 4. Subtract 18 from both sides, and I end up with negative 14, so I'm going to go up over here. 8y is equal to negative 14. Y is equal to negative 14 over 8, which is y is equal to negative 7/4. So once I do that, I'm going to plug this back up into my equation where I solved and solve for x. So x is equal to 6 plus 2 times negative 7/4. That's x is equal to 6 plus negative 7/2. And when we solve this out, x is equal to 5.5. And so my point is 5.5 negative 7/4. And this is the point that they will meet at, or they'll intersect. Alright, so I have 2 substitution problems for you to try. Come with questions. Do your best.